Scientists have discovered so much of how the world works, how people work, how nature works, and how the universe works, that it almost seems like there's nothing they can't uncover. Well, you'd be wrong. Though science has unraveled tons of mysteries, there's still tons about our world and beyond that we've barely even begun to comprehend. Will we one day? Perhaps. All scientific facts were mysteries at one point. But for now, these mysteries remain just that. Here are 10 crazy questions science simply cannot answer yet. It's generally accepted that early on in Earth's infancy, the planet was completely inhospitable. It was a hellish landscape, full of fire and volcanic eruptions and lava flowing everywhere. There's a reason we refer to that time as the Hadean era, because Earth was essentially run by Hades. Obviously there was no water then, so to speak. But then once the Earth cooled about 3.8 billion years ago, ice began to appear. But not just ice. Our world now had liquid water, despite conditions still not being ripe for it. See, that early on in the solar system's life, the sun wasn't at full capacity, and would have been far fainter than it is today. Therefore, it shouldn't have been strong enough to melt the ice, which any budding chef will tell you is the first step toward crafting delicious water. And yet there's geological evidence pointing to our surface sporting liquid water anywhere from between 3.8 to 2.4 billion years ago, long before it should have happened. As it stands, scientists have no solid clue as to how this happened. They have theories, of course, but nothing has graduated from theory to solid explanation just yet. We frame that question this way for a reason. It's almost a given that there are aliens somewhere in this vast universe. There's simply too much space, too many stars, too many planets, and too many chances for life to happen, that it makes virtually zero sense to assume that Earth is the only rock to teem with existence anywhere. And yet we have yet to meet any life anywhere else but on Earth, leaving scientists baffled as to where the aliens may be. Their confusion is reflected in something called the Fermi paradox. According to this paradox, the universe is filled with billions of stars, many of which are far older than our sun. Given all those stars, it stands to reason some of them must have Earth-like planets, rocky spheres with an oxygen-happy atmosphere that orbit within the habitable zone of their star. Given that these are Earth-like planets, at least some of them must have developed life, advanced life in some cases. And since there's no reason to think that we're the most advanced life form out there, it's highly possible at least some of these aliens have figured out how interstellar travel works, meaning that at least one group should have popped in to say hi by this point. So why haven't they? Why haven't we encountered any aliens? Are they simply too far away? Are they on their way? Have all the interstellar aliens gone extinct already? Are we actually the most intelligent species in the universe, meaning nobody anywhere has perfected interstellar travel? Or is it possible that despite it making virtually no statistical sense, we are truly alone in the universe? Perhaps the only way we can learn the answer is by developing interstellar travel and visit the Earth-like planets ourselves. A humongous chunk of space, almost all of it in fact, is just that, space. For the most part, there's no planets, stars, comets, or anything else. It's just blackness, stretched out seemingly forever. But it's not empty space. Even all that blackness is made of something, and astronomers basically have no idea what that something is. Stars, planets, and everything on them are comprised of atoms. Amazingly, despite how massive some of these structures are, they only make up about 5% of the universe. The other 95% is made up of something completely different, and we're still trying to figure out exactly what it is. All we know for now is that the 95% is made up of two mysterious forces, dark matter and dark energy. Dark matter, first discovered in 1933, seems to work as a kind of a glue. It binds galaxies, clusters, and even superclusters together, so all that stardust doesn't go randomly flying away in all 360 directions. As for dark energy, which we first learned about in 1998, that's the force that helps to seemingly expand the universe. Ever since the Big Bang, the universe has expanded more and more, and it does seem to be doing so at a faster pace now than it did before. That said, all we know about dark matter and dark energy is these basic functions. We still don't know their true identities, or what they themselves are made out of. After all, if dark matter isn't made out of visible atoms, then what is it made out of? And how is dark energy different from the energy we use every day? And which powers the visible part of the universe? Astronomers are doing all they can to answer these questions, but for now, that's all they have: questions. It's not that science doesn't know what consciousness is, it's that it currently has no idea why it is, or how it becomes a thing in the first place. On a broad, basic level, we can explain consciousness. We know that it's a combined effort of the entire brain, with the various neurons and circuits coming together to create awakeness, feeling, and awareness within an otherwise unknowing, unconscious body. But that's about as far as we've gotten so far. We don't even really know how the brain does this. Science wants to know both for our own satisfaction and because as we learn more and more about all of our brain parts working together to wake up its flesh-covered vessel, we can use that knowledge to make even better and more advanced artificial intelligence. The days of fully conscious and self-aware robots may be approaching, whether that's a good thing or not. So we mostly know what consciousness is and kind of how it happens. What we really don't know, though, is why it is. Why are we conscious, and why is any being so? It sounds like a question best left to the philosophers, but science is actively working on its own answer. One possibility, though by no means a solution, is that consciousness exists to help us survive. Basically, we're bombarded by information and assaults on our senses virtually every waking minute of the day, whether it be the news of the world or a simple clacking of our computer's keyboard. Consciousness, goes the theory, helps us process all that information, as well as manage our sensory loads and help us decide what's real and what's imaginary, or what's serious and what's not. What's more, consciousness can use the knowledge gained by processing all this information to help us imagine how the future might go, and help us make an action plan for how to deal with that future. In short, being conscious helps us adapt to an ever-changing world, according to this theory. Whether that's true or not is for science to figure out. Hopefully for your sake, you'll never find out firsthand what's inside a black hole, because it can't possibly be pleasant in there. But unfortunately, scientists can't currently tell us what's in there, because they too don't have a clue. That's because the very nature of black holes, areas of space with gravity so ludicrously strong not even light can make it out, makes them invisible entities we've not yet been able to accurately explore. Currently, science hangs its hat on one of two possibilities, neither of which sound terribly fun. One theory, called no drama, says that if you enter a black hole, you won't notice much of a change at all until you reach a point called the singularity. There, the gravity will become so strong that it will pull your body apart vertically, essentially turning it into spaghetti. Worse still is the second theory. Inside every black hole is a giant wall of fire that would incinerate you long before you came in contact with it. This firewall would violate the laws of physics, but black holes clearly don't care about our rules anyway, so a gargantuan wall of flames is not an automatic impossibility. To make matters even more confusing, Dr. Stephen Hawking theorized that we should theoretically be able to access information from within a black hole, because it's not actually in the black hole. According to Dr. Hawking, information from inside a black hole is stored around the event horizon, the point where nothing can escape, not even light, which means we could access it. Of course, this theory is a paradox, since how can information from inside a black hole actually be outside of it? We know how life is made in general, but not how the first life was made. That first life was literally something out of nothing. Something unconscious suddenly became conscious. But how? We still don't know. Scientists tend to agree on a basic primordial soup theory proposed by chemist Stanley Miller. Around 4 billion years ago, some chemicals combined and through one way or another gained sentience. But how that happened, nobody's sure. Some feel that hot pools around volcanoes gave off enough heat to kickstart biology. That still doesn't understand how heat could do such a thing. Other scientists feel the basic building blocks of life came from space, thanks to chemicals present on a meteorite that crashed into Earth. But that still doesn't explain how those chemicals came to life. It also doesn't explain how DNA became a thing, or how early cells acted. In short, if the story of how life is made were a book, we would currently be missing page 1. And until somebody turns into a real-life Dr. Frankenstein, learning how to bring life to something otherwise lifeless, that page may prove forever unread.
I'm Jamie. I'm pleased to meet you. I'm Vicky. Shake hands.
The universe is beyond massive and getting bigger all the time. Currently, scientists believe the universe stretches across an incredible 46.5 billion light years. Consider that 1 light year equals 5.88 trillion miles, and it's clear that the universe's size is beyond human comprehension. But here's the thing, that's only the observable universe. It's known that there's an unobservable part as well, and we have no idea how far that stretches, or how far it will stretch. Currently, most scientists believe the answer is it goes on for infinity, citing the path of cosmic background radiation the universe emits. This path suggests to astronomers that the universe is both flat and goes on forever. So that's that, right? Not exactly. As with all scientific studies, the universal boundaries one contains a margin of error. And if the universe has even a slight curve, one smaller than the study's margin of error, that would make the universe more of a sphere. In that case, there would be a finite end to the universe, but it would still be far beyond anything we can observe. So unless we can develop telescopes so advanced it can show us what's happening hundreds of septillion of miles away, we may never know exactly how far our universe stretches. While we obviously know what a human is, since we all are one, we don't actually know what makes a human, rather than just a highly evolved great ape. And the more you think about it, the more you realize it might not be a question science can answer. Our DNA isn't what makes us human. We share 99% of our genes with a chimpanzee. What's more, we have half our genes with a banana. It's not even necessarily our human traits. Things like language, using tools, and recognizing oneself in the mirror have been observed in animals aside from ourselves. It's possible not even religion, or at least an awareness of death, is exclusive to humans. Elephants have been observed mourning and burying their dead after all. Even money isn't 100% a human thing, as anyone who's seen penguins trading shiny pebbles in exchange for mating sessions can attest. It might well be that other aspects of civilization, cooking, skills, trade, and cooperation is what truly makes a human human. But for how long? At one point, we didn't even know other animals mourn their dead or use language, but now we do. It's highly possible we'll uncover a non-human species using fire, or developing a specialized skill. Once that happens, the question of what truly makes us human will become just that much murkier. For that matter, what's in the ocean period? A whopping 95% of our planet's waters are still unexplored. We can only imagine what's down there, especially in the deepest, darkest depths of the ocean. The issue is that the ocean goes way down. At over 7 miles deep, the ocean's lowest part is further from the Earth's surface than the peak of Mount Everest. This means no sunlight and very little heat makes it down there. Plus, the water pressure is so intense, surface dwellers simply can't survive down there. Only a couple times has man ever attempted to visit the deepest parts of the ocean. Don Walsh and Jacques Piccard did so in 1960, and Titanic director James Cameron visited in 2012. But for the most part, the adventure is so nigh impossible that scientists send unmanned vehicles down there in our place. Even so, there's still an incredible amount of the ocean floor that has yet to be explored. Considering what we've already found that far down, bizarre-looking fish, sea monsters straight from your nightmares, and even crustaceans who may contain the cure for Alzheimer's, it's highly likely that the remaining 95% of the ocean is populated by creatures we couldn't even dream about. No matter how you slice it, the sun is ridiculously hot, and yet for some unknown reason, it actually gets hotter the further away you are from it. The sun's surface temperature is roughly 5,000 degrees. While it's certainly scorching, it's nothing compared to our star's atmosphere. Called the corona, this atmosphere stretches over 1 million kilometers, or over 620,000 miles, and for some reason it just gets hotter as it goes on. At certain points, the corona's temperature can hit a whopping 2 million degrees. This, more so than the actual sun, is likely what provides much of the heat for the solar system. But why? Why would the atmosphere of something be 40 times hotter than the actual thing itself? Currently, science has no clue, likely because flying over to the sun to study it is a complete impossibility.